Hey, welcome back to our OSU Rio live streaming Thursday telecast. And it's my pleasure to co-host with Viniak Sediker the Ohio Health Soil Series, in which we talk about various different things that Viniak is involved with. Viniak is a research associate with the Soil Water Bioengineering Energy Program at the Ohio State University South Centers. We at the OSU South Centers collaborate with the University of Rio Grande and Rio Grande Community College to promote small businesses, educational programs, students, faculty, aquaculture, agriculture, horticulture, soil, and other kinds of business organizations. Our mission is very simple: to provide educational programming regarding growing our communities in Southern Ohio, in the state of Ohio, and the surrounding states, and likewise on a global basis. We have over 120,000 viewers and listeners who have tuned in to our different telecasts, which encompass 178 countries or more. This week's theme is agriculture within our universities. It's my pleasure to present Vinay Shedeker, who's going to talk with interesting guests that you brought on today.
Yes, Patrick, and thanks for having me. This is a new series we're starting. This is our second episode.
Yes.
So this is the first episode was just about the introduction to the whole series that we're going to do. And we had Alan Sundermeyer as our guest.
Yes.
But really today is the first guest, and we have a privilege to have our first guest today, which is Dr. Steve Culman. He's an assistant professor with the Ohio State University in Worcester, and he's the new soil fertility specialist for the Ohio State. So I'm just going to welcome Dr. Steve Culman here, and Steve, I think we're gonna just let you introduce yourself. Just tell us about yourself, a little bit of background, and currently what you're doing.
Sure. Well, good afternoon. Thanks for having me. And I'll just say again, my name is Steve Coleman. I am the state specialist in soil fertility, assistant professor here at Ohio State in the School of Environment and Natural Resources. I'm based in Worcester, and I have a three-way split of extension, research, and teaching. So I grew up in Ohio, but been a number of different places in terms of grad school and as a postdoctoral researcher after grad school until I came here, which was in the spring of 2013. So I'm going into my fourth year now. Again, it's mostly a nutrient management, soil fertility position, and my specialization, or I really focus in kind of nutrient management, soil fertility issues, and also do quite a bit of soil health work in terms of testing, trying to develop methodologies from a very applied perspective and try to educate farmers why soil health is important, why we are interested in measuring things and developing measurements or indicators or tests so that farmers can, or whoever can, submit samples and get that tested. So that's it's a lot of work involved in that in terms of trying to get it from a kind of a relatively newly emerging idea into something that's practical and in place. And so we work in a number of other areas, and anything in the context of what builds fertility. So looking at rotational diversity effects, cover crop effects, long-term tillage practices. So a lot of really interesting things going on now, and just happy to be.
Hey, Steve, you got my curiosity. How did you get into the soil? Was it by accident? Was it a lifelong dream? What led you to doing what you're doing today?
Well, everybody knows it's every kid in America's dream to grow up and be a soil scientist someday. And I just am one of the lucky ones that happened to actually, I think the latest poll I saw was football player, firefighter, and then soil scientist was number 3. No, I'm just kidding. But yeah, I don't know. I just it's a good question. I get asked that from time to time. I don't particularly have a great answer, except I just was exposed to agriculture growing up, and I did grow up on a farm, but I worked on farms, and summer I was the summer support, the summer help. And just kind of got interested in how much agriculture dominates our landscapes and how much it has really large implications for the way we grow food, for all kinds of globally environmental processes and the natural, ecosystem of the earth. So part of that, that's a lot of what led me down that road anyways. Yeah.
Excellent. Well, Steve, since you've been to grad school and some other job opportunities in states other than Ohio, you are from Ohio. Do you see any differences or a lot of major differences in soils in Ohio compared to other states, particularly agricultural soils with respect to quality and soil health?
Yeah, that's a good question. I most recently I came from UC Davis, and so of course things are quite a bit different out there, both in terms of soil and climate. And a lot of, in addition to that, you're thinking about different crops, and a lot of the kind of specialty horticultural crops in California are managed very, very differently, very different constraints than here. So in some ways it is quite different, right? I worked in Michigan for a little bit. Those issues are a lot more similar to Ohio. So yeah, of course, just as you might expect, quite a bit of diversity of soils and different cropping systems and regions out there. And so, in the context of soil health and soils in general, everything is place specific. And what is really primary constraints or concerns for producers here in Ohio can be quite different than they are, say, in Iowa or South Dakota or California or Washington State, Florida, wherever you're going. Yeah.
Now, I heard, and first of all, I've never grew up on a farm, never lived on a farm. The only thing that I've grown is a tomato here and there. So please understand, I'm very I'm much of a novice when it comes to agriculture and soil. But in Ukraine, supposedly they have very rich soil that allows you to grow wheat and different products there. How does their soil compare to our soil, or is it something you have not studied yet? Why
Sure.
why do they have a rich soil and
Well, they have, soils are an interesting thing, but it's a lot of, what dictates a fertility of a soil per se has a lot to do with the geologic age of that soil and how that soil has developed over time, over, millennia essentially. And so Ukraine has a lot of traditional grasslands where the native ecosystem there, and grassland ecosystems generally develop under really good soils, like mollisols, or it's the type of order that, and those, but we have those in the United States in the Corn Belt, Illinois and Iowa and parts of Kansas and Nebraska. These are where mollisol orders are, and those are oftentimes very productive soils, right? And so when you get into, say, Illinois and Iowa, when you get consistent rainfall and large, more rainfall than you would in, say, Iowa or, say, in Kansas and Nebraska, you get a recipe for very, very productive ground. And so it's a bit of how the soils, the grassland communities that those soils were developed under, but also the age of those soils in kind of a geological context. Because when you have glaciation and mixing, you get more fertility in that soil typically. Yeah.
So, speaking of fertility, you are a soil fertility specialist. is there what is the type of work that's going on in your lab or in at Ohio State with respect to the soil fertility recommendations for Ohio?
Sure. One of the big things that we're doing right now, it's consumed quite a bit of effort, is we're revising the tri-state fertilizer recommendations. And so this is the field crops, corn, soybeans, and wheat. And it's tri-state because it's a three-state system of Michigan, Indiana, and Ohio. So we're doing a lot of on-farm trials. We're running on-farm trials. This is actually our fourth season we're going into where we've done this. They're typically large plot on strips on farmers' fields. We're working with private crop consultants, with OSU county educators. A number of people were basically subcontracting or partnering with them so they can help run trials for us with the farmers. And we're doing a manipulation. So we do a phosphorus fertilizer versus a no phosphorus fertilizer, and we compare those results. Or we do, with nitrogen, phosphorus, potassium, and sulfur is what we're doing. So in next year at this time, we should be rolling out new fertilizer recommendations that will go into place. They have not been updated in Ohio, and they're about 22 years old at this point. So
Wow.
it's time for that to happen, especially with all the water quality issues. So that's a major focus of what we're doing right now. And of course, there's quite a bit of other work at Ohio State in terms of looking at the phosphorus risk index, edge of field studies, water quality kind of work, and seeing how management influences, water quality and nutrient runoff. Yeah.
So do you see, do you anticipate a lot of major changes with respect to the recommendations that will come next year, like application wise as well as the water quality side of it, where you're talking about the runoff of nutrients edge of the field or into the natural streams?
Yeah, we're not. The data that we have so far does not suggest that we're going to have major changes. So I think what will be an important thing is just to confirm that the recommendations are valid, and or maybe they need some tweaking or some modification. But there's, in the absence of any kind of real synthetic, robust analysis, there's a lot of uncertainty in terms of if recommendations that are 20 years old are still valid. So I think just reconfirmation of that will be very helpful for, giving confidence in farmers. Yeah.
So one of the things that we're involved with nowadays, the whole soil science scientific community, especially people like Steve and Dr. Rafiq Islam, a term that's coming up is soil health, and that's why our series is called Soil Health Series. So we're going to switch gears here a little bit,
Okay.
but the soil health, soil fertility specifically referred to the chemical aspects of the soil, but then as we discussed in our first episode, the soil health is a more broader term. I think I'm gonna just let Steve explain to us, just in
Good.
brief, what exactly we mean by soil health, if you can, Steve.
Sure. Well, I think that I can give you a textbook definition, or NRCS has their own, but obviously we have a really robust infrastructure in Ohio and across the Midwest and the United States in general, where it's really a buyer's market of a lot of soil testing labs that are out there and will test your soils. You can have, sample the soil yourself in your field, or you can actually contract a number of crop consultants to come and grid sample or just zone sample your soil. And they'll get you results. And those results are based on tests that, of course, have been evaluated and tweaked and kind of quote-unquote perfected, standardized at the very least over time. And that's a really important thing for understanding what a test in a lab, how that actually is calibrated and correlated with a field study. And so we have this for lime. You submit soil, you get pH testing, they'll tell you how much lime you should apply. you get a soil phosphorus level or potassium level back, and they'll tell you how much of P2O5 or K2O to apply. These are all based on soil tests that have been calibrated and correlated and calibrated with field results. And so it's easy to kind of take that infrastructure for granted. There's been a whole lot, decades of work behind that from a large variety of institutions, primarily land grants. But here we're looking at understanding that chemistry alone isn't the end-all be-all in terms of what we know about a soil, how to manage a soil. And so there's biological properties, there's physical properties. And so of course, with chemistry, we have biology and soil physics, and that really encompasses the three kind of major components of soil. So what we're really after, in my opinion, with soil health is trying to be a little bit more holistic, understanding that sometimes your soil chemistry is fine, but you might have production constraints that are due to, say, biology problems or issues or physical issues. We can think of things of like compaction or disease or just a lack of nutrient turnover and cycling that's happening with a biological community that's not very active. So we need to, if we want to manage our soils a little bit more holistically, we need to have testing that reflects that and test things that are a little bit more holistic than we have right now.
So speaking of soil testing or the soil health testing, what are some of the resources available for, let's say, our conventional farmers if they want to get their soil health assessed? What do they do?
Sure. Well, there are commercial labs. There's not many, but there are some commercial labs that are out there that offer the testing and hopefully some kind of interpretation with that as well. And so a Google search will help you find those labs. Labs that I've worked here in Ohio, Brookside does probably the majority of the soil health testing in terms of the large labs. There are probably other smaller labs that do that work as well. Cornell Soil Health Lab has really been kind of pioneers in the field, and they do commercial testing as well. So, and that's not an exhaustive list by any stretch, but there are a number of labs that are out there. So, I'll say if you're interested in that, there are opportunities already. The issue really is, they can generate a value, but really understanding what that means and what the implications are for that management, that's a little bit tougher nut to crack, and it's kind of where we're at right now. We're trying to understand a little bit better. So I don't know if hopefully that answers your question.
So let's back up a little. You mentioned about a value. So essentially what he's referring to is you do your individual soil testing for individual properties, and each property is going to be assigned a score based on whether or not that's a good indicator or bad, and the level of that indicator in the soil. And then all of that comes together into a combined index, which Steve is referring to. And your recommendation is that you cannot just rely on that one single number, but you really need to look at what the actual soil properties are, and then make recommendations based on that. Is that right?
Yeah, this is an axe that I like to grind a lot, but it's this idea that we would love. I mean, everybody would love to have all the entirety of your soil properties condensed into one single number, and that would be most labs that offer testing give you some kind of soil health index or indicator or something, and it's usually scaled. It's like 1 to 10 or 1 to 100 or something like that. So to me, that really defeats a lot of the purpose of soil health testing, where we're trying to look at individual components, think of it holistically, and trying to consider those different pieces together. But trying to boil those down into one single number is challenging. And you can have two soils that both have a score of 75 out of 100, whatever that might mean. But they could have entirely different issues in terms of what's limiting the primary constraint to production. And
Okay.
so, and this of course is coming at it from kind of an agricultural perspective, recognizing that soil health can be, it's potentially valuable for people that are that do agriculture, as well as other kind of other types of landowners that might not be farming or whatever. But so I just think that we need to be kind of realistic when we're thinking about soil health testing. That we don't want we need, if you're going to have 5 different tests run, looking at each one of those tests in isolation and then holistically is a good approach. But trying to condense all that down into one single number is in my opinion, not a recommended thing to do. Yeah.
Didn't you bring a picture of some of the soil testing and what some of the results are?
Yes, let's talk about that. I think you brought some pictures from your own lab. So let's talk about what particular indicators you prefer doing and what type of work you do in your lab with respect to the indicators of soil health.
Sure. So we do, really, since I do a lot of on-farm work and I consider a lot of my work to be very applied. We do a number of tests, not a whole lot. You can run 50 different tests on a soil sample, but the analysis is going to cost you $1,000 or $2, right? So we want tests that are identified as very rapid and affordable, and something that a commercial testing lab is really going to want to do. So things that require a lot of labor, a lot of maintenance, a lot of operator training or input, those are not tests that are very good in our opinion. So what we're looking at now is one of the things that we think is a very, very good test, perhaps one of the better indicators that is out there. And this is what we call active carbon, or scientifically POX, permanganate oxidizable carbon. This purple solution in the tubes that you see here is this brilliant purple or pink. It's a permanganate, and when that hits organic matter, that gets consumed. It gets used up, and it will essentially go from dark purple to clear, just like you see on the screen from the right to the left. So this is a very simple test. It's a measurement of how much available carbon or active carbon, that active organic matter. So how much food is available for the microbial community. We believe it's highly related to microbial biomass and total microbial community size. We think that we know that it reflects processes from organic matter building. So some of the work in my lab showed that as this measurement gets up, so if you have things like conservation tillage or cover crops, this is something that will influence this indicator, and that will, that total level will increase with conservation practices. So we think this is a very nice, very rapid test, and can be used quite widespread, but it's really not being used too much at the moment. I mean, there are some labs, but it could be used a lot more. So this is kind of a sleeping giant in some ways.
So this is good. This is one of the indicators of soil where short-term change in your management practice is going to show you. This test will kind of reflect the benefit of that particular change in management practice.
So if I'm understanding correctly, if it's too purple or not enough purple, we add something to increase whatever needs to be increased. Is that right?
Yeah, I mean, I think that part of this, when you have the less purple, the better, because that basically means that there's more carbon or more organic matter in the soil. And so as there's more, that permanganate gets consumed and essentially goes clear. So, if you have the opposite use submit soil and it's very, very dark purple, it means there's not a lot of available carbon. And so there's a lot of things that we can do to help influence that. You can add things like manure or compost or some kind of organic amendment, but preferably you do it a little bit less expensive way, things like conservation tillage and using cover crops or increasing your rotational diversity. So,
Sure.
again, you can do that with cover crops. You can do that with small grains. You can do that with just more diverse crop rotations. Those are the kinds of things that will really affect this measurement.
So we have about a couple minutes left in this, and I just want to make sure we cover all the slides. So let's
Sure.
move on to the last one, where and then I will let you tell us about a little more about your another indicator that you recommend with respect to soil health.
Sure. Yeah. So this is one. Anthony Fulford here is showing us what we call soil protein. This is a kind of a methodology that was used in another context, trying to look at soil fungus, but we found that it's a very sensitive indicator. And this kind of test for soil nitrogen is it's a bit of a holy grail of soil science that kind of remains to be elusive. This is a test that looks at an organic fraction of nitrogen. And so really there's the two main ways that we measure nitrogen. One is total nitrogen is a very stable measurement, and inorganic nitrogen, or things like nitrate and ammonium, that's a very rapid measurement when it just fluctuates wildly over the growing season. And so this is a measurement that hopefully straddles that line and is a little bit more sensitive to management, but just doesn't spike and drop and everything else. So soil protein is a measurement of total organic nitrogen, or it's an active fraction of
Okay.
organic nitrogen.
Okay. Well.
I find this very fascinating. Boy, I would love to have Steve come back on and
Yes.
talk more, because as he was talking, I had lots more questions.
I think we definitely need you back here to talk in detail about some of these tests. We're
Sure.
running out of time, so
Yes.
we definitely want to thank Dr. Steve Culman for being our guest today and talking about soil health assessment. And
Great.
thanks,
Well,
Patrick.
thanks for having me.
Thank you. And Dr. Coleman, thank you.
Thank you.
I'm Patrick.
I'm Vinayak, and this is the Soil Health Series.